All right. Well, hopefully everybody did an awesome job finding our confidence intervals if the population standard deviation is given. So again, like I'd mentioned before, that's going to be a pretty realistic thing to know because in reality, if we know the population standard deviation, there's probably a pretty good chance that we would actually know the population mean, and there wouldn't be that much reason to go and actually estimate what the confidence interval would be for the population mean. So the more likely situation is the one we're working with now, where the population standard deviation isn't known. So the good thing is, since we can use our sample mean as a point estimate for our population mean, we can also use our sample standard deviation as a way to estimate our confidence interval. So pretty much this formula and everything else is going to be exactly the same, except we're going to swap out the sigma for our S for our sample standard deviation. Now, there is one new thing we're going to get. So instead of using our normal distribution like we've been using for all these other ones, we're going to introduce a brand new distribution, which is what's called our student t distribution. And so again, it's still approximately bell-shaped. It's still approximately normal. It's a little flatter and a little spread out compared to our normal curve. But again, the big difference is the t in this case tells us that we're going to start working with t-scores instead of z-scores. So again, sometimes it's hard to hear this in the videos. So z-scores, sometimes I'll call zebra scores. T-scores, I'll call tiger scores, just so we kind of know the difference between them. So when the sample standard deviation is known, we're going to be using the student t distribution and t for tiger scores for these guys. And so one other thing that comes up is this idea of the degrees of freedom. And so we are going to have to know what that is in order to help calculate our t-score to go with these different values. And so in these types of problems, the degrees of freedom is going to be the number of people sampled minus 1. All right, so if we look at our margin of error, so again, the only difference we can see with our margin of error is instead of using the zebra score, we're going to use the tiger score. And again, our standard deviation we're using is our sample standard deviation for this. And then again, just for a little picture, so this is what a typical t-distribution would look like. So it's still basically a bell-shaped curve, but it is a little wider and a little flatter, especially for smaller degrees of freedom. If the degrees of freedom start to get pretty big, then a t-distribution pretty much models a normal distribution exactly. But for small degrees of freedom, they can be a little bit different. And then again, the nice thing is we can use this t-distribution for small sample sizes, like even 3, 4, 5, things like that. So where again, unless we know it's bigger than 30 or normally distributed, we can't actually use the normal distribution for those. All right, so the only tricky part is finding the t-value or the tiger value for these guys. So some people may not have this feature depending on how old your calculator is. So, but what we're looking for is a feature called the inverse t. And if people don't have it on their calculator, just let me know because I've got a program that we can use on Excel or Google Sheets to find it. And then I also have a table that you can use, but the table is not always the most friendly to use, but I did list the table here just so we could get an idea of how to use it in that case. So for example, if we wanted to find a t-score that had a 0.05 alpha level with 6 degrees of freedom, 6 degrees of freedom, then what we would do is start in the 0.05 column, and then we'd go down to where our 6 degrees of freedom were, and we'd see that our t-score that goes along with that value would be the 1.943. And so again, the only downside is like the table is pretty limiting because you can see we only have some of the most popular choices here. You know, if we wanted to find alpha level of 0.02, it's not on the list and things like that. So the calculator is a much more accurate way to do it. So if you don't happen to have that inverse t command on your calculator, definitely let me know. And so I can make the Google Sheets available to everybody so they can use them. All right, so I'm going to show you for example one, how to find this using the t-score using the table and using the calculator, so we can see how to do it. So for example one, we've got to construct a confidence interval of 90% with a sample of 7 items. So for this one, we've got our 90% confidence level tells us we're going to have an alpha of 0.10. Our n is 7, which means our degrees of freedom is 7 minus 1, which is 6. So for our table version, if we go up to where the alpha equals 0.10, we're going to be looking at that first row or first column. And since we want a degrees of freedom of 6, then we want to follow along this yellow line. And so it looks like we're going to end up with a t-score of 1.440 for this one. So our t is going to be 1.440. All right, so now if we're using the calculator, this is similar to inverse norm. So what we're going to do is, again, start off with our percentage that we're trying to find the area under the curve. But with this one, since everything revolves around the degrees of freedom and not the mean and standard deviation and things like that, then the next thing we're going to type in is our degrees of freedom. So there's only 2 things to type in. So we've got our alpha and our degrees of freedom. That's the only thing we type in. And so the good thing is inverse t is located in the same place inverse norm was. So if we hit second vars, and so notice number 4, if you have it on our list, is inverse t. And so we're going to put in our 0.10, comma, our degrees of freedom. And then lo and behold, we get, of course, the negative version of this, but negative 1.44 rounded to 2 decimal places. So we do end up with the exact same thing. So again, ours came up as negative 1.44. But again, remember, this is going to be symmetric around our normal, like the standard normal. So again, the 0 would be the mean and stuff like that. All right, so try practice 1 here. Make sure you can find this either using the chart or using the calculator, either one. And then we'll come back in a little bit and just talk about some of our confidence intervals. So good luck.